Why do I have, oh yeah. Hello, good day. We are in Algebra. We are correcting CO17, going over that. Boys, beep, beep, ding, happened. Correcting CO17, and then we'll be talking about the practice test, getting all of your questions, hopefully all of your questions answered before the test for realsies, which will be tomorrow and Wednesday. So the second page of CO17, we did some of these together. Did we do the first one? No?
We did the bottom left.
Bottom left, I remember that one. It took like the entire page, but in the middle, okay. All right. So the biggest thing that was probably throwing off the seventh graders, and really historically too, is that you can't break it into your compound inequality. You can't write your and or your or statement until the bars are by themselves. So this top row, everything's set. Right, you can go straight to your or, straight to your and, or whatever you got to do. But the three on the bottom here, like we saw in particular, that one on the left there, you got to do some prep work first. Okay, so don't be so quick to jump to the compound inequality until you isolate the bars. On the first page, it's that goal, isolate bars. That was first, then rewrite as a compound inequality. So in any case, here we are. Absolute of x plus 4 is greater than or equal to 3, and or statements. Here, and or statement. Elise. Or, how can you tell, Elise? Any special helpful tricks or hints that you use? Oh, a greater symbol is going to be an or statement. Copyright, patented. That's all good. Okay. Or. So we have x plus 4 is less than or equal to negative 3, or x plus 4 is greater than is greater than or equal to positive 3. Okay. Notice that what's inside the bars doesn't change, right? It's just we need that value x plus 4 to be on the left side of negative 3 or the right side of positive 3 so that it's further than 3 from 0. The first page really goes into detail how we can think through that. But from this step, we can solve separately. X is less than or equal to negative 7. Subtract 4 here. X is greater than or equal to negative 1. We see this is going to be an or statements. Our graph is going to reflect that as well. Open or close circle going left, close circle going right. Okay. Questions on that one? All right. Second one you said we did together?
No.
I don't remember. So. This is an and statement. It's by themselves. It's ready for us to put into our compound inequality. It's going to be negative 10. It's less than x minus 5, which is less than 10. The value of x minus 5 is within 10 of 0. So it's between negative 10 and positive 10. This one, being an and statement, we kind of solve it all at once, adding 5 to all three parts. Negative 5 is less than x, which is less than 15. And your graph should look like that. Like that. Okay? The last one here is sneakily quirky. Bars are by themselves, so we can go ahead and put it into 14 minus m is less than negative 6, or 14 minus m is greater than positive 6. Subtract 14 from both sides. Negative m is less than negative 20. And in this case, because m is negative, we have to make a positive. We do that by dividing by negative 1. It's not written, but it's got that coefficient of negative 1. And so we get m is greater than 20. Okay, our sign flips. The 20 becomes a positive. So does the m. And there we have it. Same thing happens on the right side here. Subtract 14 from both sides. We get negative m is greater than negative 8. Divide by negative 1 to get m positive. And our sign flips to be less than. Why it's sneakily quirky is not only that, but now when you graph it, you have to make sure that you put the numbers in the right order. 8 is on the left, 20 is on the right, and it is an and or an or statement. Okay? Good so far? Okay. The bottom one, the first one we're not going to do, so I talked about that one. We did the second one together apparently as well. So we'll jump to the third one, where we have other stuff that's got to happen before we can get it into our compound inequality. It's almost like you're treating the bars like a variable themselves, right? If this read, 5n minus 7 is greater than 13, well, to get n by itself, you'd add 7 and divide by 5. Kind of the same thing we're doing here, just to get the bars by themselves. Add 7, that gives us 5 times the absolute value of x plus 8 is greater than 20. Divide both sides by 5. And we get the absolute value of x plus 8 is greater than 4. Okay? And or statement. Or, greater symbol. That didn't work. There we go. So we can write that. X plus 8 is less than negative 4. Or x plus 8 is greater than positive 4. Again, what's inside the bars doesn't change. Just on the left side of negative 4, the right side of positive 4. Subtract 8, subtract 8. X is less than negative 12. The other one, x is greater than negative 4. Here's the graph. And there you have it. Questions on that one? Is it hot in here? Or is it...
Yes.
I had 3 pieces of that garlic bread. I'm trying to decide if I've just got like the, garlic sweats or if I'm, it's toasty.
Or if the garlic breath is coming back.
That could possibly. All right. Anything with those 6 that you want to talk about? Anything more with those? Okay. There was a question like the Brain Buster on your practice test. So you got some experience with it there too. We kind of talked about how to set this up in that you're looking for the value for n that works in both inequalities. Okay. So I said solve them separately, graph them together, right? And look at where those graphs overlap, because that's going to show you the values that work in both of them. So for the first one here, we can set it up as negative 1 is less than n minus 2, which is less than positive 1. Add 2 to both sides, and we get a solution range between 1 and 3. Okay. The second one being an or statement, n plus 6 is less than negative 7, or n plus 6 is greater than positive 7. Subtract 6, n is less than negative 13. Subtract 6, n is greater than 1. So when we graph these now, okay, our first one has solutions between 1 and 3. So it's going to be an and statement there. Our second one is less than negative 13 and greater than positive 1. So what's a possible solution for n? Being it's going to work in both inequalities. Gabby? 2. Why? Well, because 2 on our number line is right here, right? And it's a solution in both of them. What else? 1. Why not 1? Why not 1?
Because it's not equal.
Because it's the open circle, right? 1's actually not a solution to this, okay? For closed circles, then you would be correct, but 1 is not. So what else is? 2.5 is in between 1 and 3. What else?
1.5.
1.5 would work. Yes.
1.75.
1.75.
2.75.
2.75. That's all you got? Okay. Yeah, so anything between 1 and 3 is going to be a solution. If you pick something negative 13, below negative 13, it's only going to work in the or statement. Anything greater than 3 is only going to work in the or statement. Anything in here isn't going to work in either because there's no graph there at all. So, but the one we're looking for is between 1 and 3. So on your practice test, it was a similar setup to this. We're just graphing both of them on the same number line and seeing where they overlap. Yeah. You could guess and check. That is that's always an option. The problem though is that unless you guess right, it's not very efficient. Who knows how long until you find the correct answer. And in a timed test situation, you might not want to go that route.
Yeah.
Yeah, I mean, you have 2 class periods to do it, but I mean, if you think about like the ACT, that is a strict 1 hour. I know you probably haven't thought about that yet. It's still 3 years before you get that age, but that's a situation where you don't want to spend half your time on one question, right? And if you're guessing and checking, just not very efficient. Guess and check. I mean, guess and check is not a bad method. If you really are all out of options, it's not a bad method. It's just not very efficient. Like if you needed to pound in a nail and you couldn't find a hammer or a tape measure or a screwdriver or anything, I mean, you could use your fist, or you could was that me? Someone just shot a pen at me. What was that?
First it was Gavin, now it's Amber.
I know. Gosh. You could use a spoon, right? It's not very efficient, but it could happen. I'll stop telling metaphors if people are going to start throwing. Anyway, other questions on CO17? Okay. On to your practice test then. I'm going to give you the answer key, and I'll give you a couple of minutes just to kind of peruse through it, see what you might want to ask questions on and what you don't. So while I do that, I'll pause the video, and we will pick it up in short order. Over it. We are back with our practice test. So anything that you want to talk about, the PO9, which again, note the POs. Okay, those things that you're gonna have to pass eventually. So it'll just be better off for you to pass it the first time around than have to do the practice work and the retakes and all that sort of stuff. So PO9, basic equation solving. You'll notice that numbers 3 and 4, your variable isn't. Your variable is your solution, right? PO9, it says I can write and solve equations. So some people that emailed me over the weekend were trying to stick their variable somewhere within the equation, like you have to solve for it. But really, he rakes his leaves in a pile of exactly 225 leaves. His collection bin already has 30 leaves in it. How many leaves will be in the bin after 3 of my piles are added? So 3, oh, I gotta change. Wait, why is this not working? Hold on. We'll try red. Nope. How come this is not? We're going to pull an audible here. We're going to try and close this, close that, reopen this, and see if that fixes things.
Hey, put it up.
All right, there we go. Folks, we are recording. Please quiet. Thank you. So I'm putting 3 of my piles, each with 225 leaves in them, plus the 30 leaves that are already in the bin, and that equals the total number of leaves that will be in the bin. So your variable isn't within the equation, it's the solution here. But part of what PO9 is looking at the verbal and figuring out what the operations are, what's my constant, what's my coefficient. It's not always, the variable's going to be in the middle of things. It might just be answer the question. Okay, so someone earlier said they had a question on PO9. Bridget, did you get it figured out? Okay. Question? Okay. Anything else with PO9? Okay. Looking at PO10, anything you want to talk about there? Standard equation solving, just straight up algebra, combine like terms, distribute. One thing you got to watch for, number 7. For this one, make sure you're distributing in the -3 first and not subtracting 4 and 3 and distributing the 1. That multiplication has to happen before you subtract. That 4 is nothing to do with the parentheses. right? So your second step here, as you can see on the answer key, should look like this. Whoops. Right, and then you can combine like terms and go about your day there. So, but just watch out for that. Anything else with PO10? Okay. CO11, absolute value equations. It's been a while since we've done these. We've done absolute value, obviously, in CO17, but absolute value equations also require you to get two solutions here. Okay, it's not a compound inequality because they're not inequalities, but you do need two values for x. Go ahead.
For 9.
Yeah.
My second answer, I got 11, and it's supposed to be 12.
So once the bars are by themselves, right? That was the first part of the goal for CO11 also. Once they're by themselves, then you can break it up into your two equations to solve, right? Because 2n minus 6 being equal to 18, that means that this value, 2n minus 6, whatever it is, has to be 18 from 0. Not more than 18, not less than 18. It's not an inequality. It is 18 from 0, which means that 2n minus 6 has to equal negative 18, or 2n minus 6 has to equal positive 18. The two numbers that are exactly 18 away from 0. So from here, you'd add 6 to both sides. 2n equals negative 12 divided by 2. We get n equals negative 6. Add 6 to both sides here as well. 2n equals 24 divided by 2, and n equals 12. So I'm not quite sure how you got 11. If you had this, did you have this equation written? 2n minus 6 equals 18?
And I see what I did wrong.
Yeah, you probably just added this wrong.
That's what I did.
Yeah. So, but again, checking that answer would help, right? If you plug in 11 to this, 2 times 11 is 22, minus 6 is 16. That's not the same as 18. So, anything else with 11, the absolute value equations? What's that?
I said never mind, I got 12. I just accidentally put down 11.
Oh, I hate when that happens. Okay. Number 10, there's some stuff that needs to be done before you can solve it. Add 5, divide by 3. You can see it there on the help sheet, or divide by 8, sorry. See it there on the answer key. And then you've got your two equations to set up there. So 11 and 12 both have to do with absolute deviation. Anything you want to talk through with on those if my answer key didn't help? Nay?
Hey.
All right, CO12. Anything here with isolating a variable? Yeah, Audrey.
So for number 13A, why would you like this?
Good question. Yeah. So when we first talked about the distributor property back in PO10, I said that there are other ways to get rid of parentheses, but that particular day we were learning that particular property, which is why we used it. The problem with distributing 8e plus 8g equals 24, some of you probably ran into the situation, well, where do I go from here, right? Now that you've given that 8 to both the e and the g, it kind of complicates things. You've given e a coefficient when you didn't have to, right? It didn't have one to start with. So instead of distributing, what's another way to get rid of parentheses in this particular situation? Julia? Right, since we're multiplying the parentheses by 8, the opposite of that would be dividing by 8. Kind of like what we do with absolute value, right? When you can't distribute in the absolute value bars, okay, we're going to kind of use that same idea here. Divide by 8, that gives us e plus g equals 24 divided by 8, which is 3. And now, all it requires is subtract g from both sides, and you get 3 minus g. Okay. Please. Yes, if you did distribute, it's not unsolvable. You'd still move your g term over. So you get 8e equals 24 minus 8g. And then when you divide by that coefficient to e here, Remember when you divide or multiply an entire side, you're dividing everything by 8. I can actually probably write that better for you to understand if you aren't familiar with this. But you're dividing both the 24 by 8 and the negative 8g by 8. Everything. So on the left side, e is by itself. On the right side, 24 divided by 8 equals 3. And negative 8g divided by 8, the 8's cancel out, and you get the same answer here. It's just a little bit more complicated. But okay. So for 14a, solve for n. We've got this fraction here, n minus m divided by h equals b. As with any fraction, we want to unfractionalize it, right? Multiply by h. That gives us n minus m equals b times h. We don't know what either one is, but we're multiplying them together. Okay? And then we're going to add m to both sides to get n by itself. And on the right side, we get bh plus m. Can't combine anything. It's all variables. But if we knew what bh and m are, which I then give you values for them in 14 part b, you can plug them in to solve for n. Okay? So it's still opposite operations. It's just more variable heavy. Okay? Questions on 12? All right, 13. Writing inequalities two ways. Anything to talk about there? You will need to write them two ways and graph them on your test. I bolded, I underlined 2 because it oftentimes gets forgotten. If you make a mistake on this section, it's probably going to be because you only wrote one inequality rather than 2, or you forgot to graph it. Just read your directions carefully and follow them. Anything? Okay. 14, solving two-step inequalities. This is where we were first kind of introduced to the flipping the inequality symbol rule. So 19, you had to provide me an example for which you would need to change the direction. As long as you have a negative coefficient to the variable, then that's what you need. Questions on CO14? Okay, CO15, multi-step inequalities. Similar to multi-step equations, PO10, only now you have to graph your solution. Variables on both sides, distributor property, combining like terms. Just pay attention to that when you flip your inequality symbol rule. Yeah? Yes, decimal forms are fine if you don't want to put it in fraction form. Either way. Going once, going twice. Going thrice. No, it's gone. Okay. CO16, compound inequalities. Your and or statement is given to you. Anything here? No? All right. CO17, what you did for homework for today. I give you 4 examples here just to give you 4 opportunities to practice, I guess. Anything? Just remember to get those bars by themselves and know if you're putting into an and or an or statement. Julia. Sure, 27. Similar to the brain buster we had on the homework, you've got to solve each of these separately and just graph them together. So this first one, negative 7 is less than x plus 5, which is less than positive 7. And then we'll subtract 5 from all 3 parts, and we get negative 12 is less than x, which is less than, I can rewrite that, less than 2. Okay. Then the other one, we've got x minus 6 is less than negative 2, or x minus 6 is greater than positive 2. Add 6, both sides there. Add 6 to both sides here. And that's what we get. Okay. So then graphing this now, we're going to graph them both together. The and statement is between negative 12 and positive 2. So negative 12 is down here. Positive 2 is here. anything within that range is going to work for that one. Our or statement, x is less than 4. So here's 4, x is less than that. And then or greater than 8, so here's 8 greater than that. Basically, anything that works in the and statement is also going to work in the or. Okay? So anything where those graphs overlap, which would be between negative 12 and positive 2, is going to work in both of them. So negative 10, 1, I almost said 3, would that be embarrassing? 1, 0, okay? It works out to be that way here. Yeah? Sorry, say it again. Oh, because the question is, what is the value for n that is a solution to both of them? So n represents the solution to both inequalities. And since anything within this range, which also happens to be just the solution, the and statement by itself, anything within that range will work in both inequalities. That's why I wrote that. Negative 12, or n can be anything between negative 12 and positive 2. Does that make sense? Okay. Yeah. On the test, I think you just have to give me a number. Yeah, it says what is a value for n, not what are the values. So if you just put 0, that would be fine. The pre-algebra review 2, there's a little bit of graphing that needed to go on here. Obviously, your answer for that XY table could change. But basically, when you graph it, it has to be a straight line. If your graph is kind of going like that, then you did something wrong. Okay. This graph should be straight, going up from left to right across the corner plane. And then for the 2 about slope, that's the formula for slope. I recommend putting it on a help sheet. It will not be on your test for you tomorrow. So if you like, oh, I remember doing that last year. Yeah, that's right. Okay, put it on a help sheet. Make sure you simplify answers. You'll notice number 29 simplifies down to be half or negative half. So make sure you do that. All fractions, always simplest form. Questions on that? Okay. And then we have the algebra review. So 4 questions on objectives we've already covered so far this year. 1 question will be from CO1, 1 from PO5, 1 from CO6, and 1 from CO7. So if you still have your help sheet from Unit 1, I recommend that you use it here also to help you remember those things. Anything else? Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Are we feeling confident?
Sure.
I hope so. Okay, I hope so. At least know there's no need to rush. It's a 2-day test. No need to rush here. Okay? All right, that is How You Math.